Speedform is built to provide detailed concept models quickly. Now that we have the concept model ready to share with others, the question is, what can we do with the data? In this video, we will see multiple ways of using Speedform data downstream. Let's start the discussion with Alias. I've selected the Send Alias menu item, which packages up the T-spline data and outputs it to an Alias wire file, and then finally opens the data up in Alias. One button transfer of the concept model to start the detailed design. Impressive. By highlighting the surface patches, you should see a few things. One is that every T-spline element is now an alias. Each surface is selectable and modifiable. The surfaces have continuity, and there are way too many patches. Obviously, this is not a Class A surface model, but the B-spline surfaces are usable, can be extended to make a more reasonable patch layout, or used as a direct reference for rebuild. This can be significantly easier than having to rebuild a model like you would with a mesh modeler. You should also notice that the Speedform curves are included in the transfer process. In this case, I'll use the curves to project to the front surfaces. The Send to VRED menu once again packages up the Speedform data and starts VRED with that data. Again, one button transfer. Since this was a single body inside of Speedform, we have a single body structure inside of VRED. By selecting the surface components, we can group the windows and the windscreen so that you can place different materials on them. Using VRED in conceptual design process is a great way to see your product in a fully realistic environment, and most importantly, used for reviews with the designer and the concept team. As we start working with other forms of downstream data usage, one thing we should consider is making the model a solid part. This will make working with 3D printing and CAD systems much easier. We've isolated just the body, and then thickened the structure inwards by 2 millimeters. Next, we'll convert the body. This takes a moment, so we'll jump to the end of the result. The great thing about being able to create a solid inside of Speedform is that the concept modeler has the ability to control the shape, even to the solids. Now that we have a thickened part, we can use this data to create a 3D print. After selecting this option and the data, Speedform generates the mesh. Because we have the preview mesh selected, we can see this mesh model. We will use the built-in Mesh Mixer application to verify and repair the mesh so that the files can be 3D printed. Using the same thickened part, we can also output the file for CAD and engineering purposes. I will use the step output and then load the file into Autodesk Inventor. We want to use the solids, not the surfaces here. The file is now loaded and ready to start engineering investigations on the model. I can materialize the data from a wide selection of shared Autodesk materials, or my favorite materials. The engineering team wants to investigate grill options for the front fascia. Therefore, we'll use the extrude to isolate the fascia. Next, we'll use plastic features to create a grill. Using a sketch we created earlier, we'll start with the boundary, then the island, and finally the ribs of the grill. All done directly on Speedform data. In this video, you should have noticed the simplicity of moving the concept model downstream to other applications. We sent the data for Alias for detailed design. We sent the data to VRED for design reviews. created a solid model, created a 3D print model, and sent the data to our CAD system to begin the early engineering investigations.